Okay, this will be a revision video split into two parts. So the first half, we're going to look at the first 3 stages of our investigation. The second half, we are going to look at the final 3 stages. And I'm going to focus specifically on our rivers field work. So what we did when we went to Cardiff Mill Valley, how we planned it, what data we collected, how we presented it, then what we found and concluded, then how we evaluated it. So how can we actually improve our investigation if we were to do it again? So introduction and planning, the first thing we need to think about is our location. So where did we actually go? So our location, we went to the Ashbrook River, and we went to Cardiff Mill Valley. So that was our location. The second thing we need to think about is our inquiry questions and hypothesis. So an inquiry question is a question that we can realistically go and evaluate and find an answer to. And a hypothesis is a prediction of what we think we will find. So inquiry question and hypothesis. A good inquiry question should be specific, so we can't just say what was the river like. We are not asking anything specific there, and it must be measurable. So we can't ask how long the river is because we can't go and measure that ourselves. So a good inquiry question should be both specific and measurable. Then one of our inquiry questions was, how does the Ashbrook River change downstream? And we could be even more specific and say, how does the velocity change downstream? How does the width and depth change downstream? Then, as I've already said, a hypothesis is our prediction of what we think we will find. So our prediction was that the velocity, width and depth will all increase downstream. We also could have included that sediment size will do the opposite, and that will decrease downstream. And our hypothesis is based on the Bradshaw model. So the theory that we used was the Bradshaw model. And this is that diagram that looks a little bit like this. So lots of triangles. If the triangle gets smaller, that decreases downstream. If the triangle gets bigger, then that increases downstream. When we are also planning our investigation, we need to do a risk assessment. So the purpose of this is to identify any risks and look at how we can manage those to ensure that we're safe when we complete our field work. So before going on any field work, we must complete a risk assessment to identify if anything could go wrong and cause potential harm. Then the idea of that is, if we do find anything that could cause potential harm, we need to put things in place to ensure that we are safe. So for example, a student could slip. To mitigate this, so to stop it from happening, or if it does happen, to make the impacts less severe. To mitigate this, students will wear sensible footwear. So that is our introduction and planning stage. Next, we are going to look at methods and data collection. So in our investigation, we used secondary data. So we used Google Maps to select our sites and for navigation. We also used a flood risk map. Flood risk maps were used to ensure we knew potential areas that could flood to complete our field work safely. Then thinking about our sampling. So please don't get mixed up between methods and sampling. Our methods is what we actually go and do. So we did a cork drop test to measure the velocity. We went and we used a tape measure to measure the width of the river. Our sampling is how much of it are we doing. So we can't possibly measure every sediment in the river. So we pick a sample, we pick a few, and we hope that that represents the whole thing. So there are three types. One is systematic sampling, and this is where we do something in intervals. So we measured the depth every 10 centimetres. Random sampling is where we do something by chance. So we can look away to select a sediment to measure. Then the final one is stratified sampling. And this is where we split the population into groups. So we measured 3 sites. So we couldn't go to everywhere on the river, so we've split it up into a lower course, a middle course and an upper course, and we have measured those 3 sites. The next thing we are going to look at is our methods. So specifically what we went and what we actually did. So we looked at the velocity, and to do this we used the cork method. So we measured 10 metres with a measuring tape, and we used a stopwatch to time how long it takes the cork to travel 10 metres. Then we can look at the width. So we used a tape measure to measure from bank to bank. We measured the depth using a meter stick, and we also measured sediment size, and we looked at sediment angularity. So was the rock round or not? So, and we used to measure sediment angularity, we used the powers of roundness chart. Remembering that you may be asked to evaluate these methods. So what is reliable about each one? So when we're thinking about reliable, we are thinking about if it's consistent. So did we do it the same each time? and if it's accurate, so if it's true to the real life value. So the velocity, it was reliable because the same person did it each time, so it's being dropped from the same height. However, it might not be accurate because the cork could have got stuck on something. Sediment angularity, to make it reliable, the same person has to do it because it could be based on your opinion. What I think is rounded, someone else might think is very rounded. The very last thing I'm going to look at on this video is our third section, and that is data presentation. So when we got back, how did we show what our data was like? So we can use a line graph to show a cross section of a river. So what is good and what is bad about that, it allows for visual comparison. So I could put a few next to each other and I would know which part of the river was wider and which was deeper. However, it's hard to see is exact values. So on a line graph, often on that y-axis we have intervals, so it could go up in tens. And if something's here, it's hard to see. It might be 16, it might be 17. It doesn't show me that exact value. We also used a bar chart to show the sediment angularity at each site. And again, it's good for comparison, so we can see straight away which site has the highest number of angular rocks and which site has the lowest number. This is bad because it gives no geographical context. So on my x-axis of this bar chart, it would just say site 1, site 2, and site 3. It doesn't actually show me where site 1 is in comparison to site 2. So it doesn't give me that geographical context. In the next video, I'm going to go through the final 3 stages, so data analysis, conclusions, and evaluation.